So before I return to my regularly scheduled trail programming, I thought I'd put together a little video called Hiking Science. Most of you know that I was a science teacher, so I thought it would be fun to explore some of the scientific concepts I see on trail. And while I designed this video mostly with my students in mind, I think it might be fun for anyone. Thermodynamics, that's the study of how heat energy moves. And one of the main principles of thermodynamics is that heat energy travels from the thing that's warmer to the thing that's cooler. And I make body heat, and human body is typically somewhere in the vicinity of 98.6 degrees Fahrenheit. And so the environment around me is usually cooler than that, so my body heat radiates outward into the environment. One of the things I could do to stop that is put a coat on to help keep the heat in, and we'll talk a little bit about insulation in another lesson. But I can also put a barrier. When I sleep at night in my tent, if I'm lying on the ground and I'm warm and the ground is cool, all the heat energy is going to flow out of my body and into the ground. And there's so much ground around me that it's just going to keep taking the heat and taking the heat and taking the heat. And even if it's not below the freezing point, I could still end up hypothermic, basically on the way to freezing to death. So one of the things that I do is I put a mat. And this mat is actually a barrier between me and the ground, and it's going to stop the flow of heat energy from my body into the ground, and this goes a long way to keeping me warm at night. You would think my sleeping bag would be one of the main things that keeps me warm at night, but without this, the sleeping bag wouldn't do me much good. So this little sleeping mat is not just for keeping me comfortable, but also for keeping me warm. Hey, let's talk about insulation. So insulation is designed to keep heat from moving from the warmer thing to the colder thing. It basically blocks the flow of heat energy. It is not going to stop the transfer of heat completely, but it certainly slows it down so that the warm thing will stay warm for longer. This is my down hoodie. It's a jacket, it's filled with down feathers, and down makes really good insulation. I have a down hoodie, and I also have a down quilt that keeps me warm at night. It keeps the body heat from leaving me and going out into the environment around me. What makes something really good at insulating is its ability to trap air. And the down feathers in this jacket, in addition to the ones in my quilt, they're all kind of going different directions with all these little gaps and air spaces in between them. And trapping air helps to block most methods of heat transfer. It blocks conduction because the molecules don't hit each other as well. It blocks convection because you can't get a convection current going when you have the air molecules trapped together. So some of the things that make the best insulation: down feathers, foam, a thermos because it traps a layer of air between the inner and outer layer of the thermos. All those things that trap air make really good insulation. Hey, more hiking science. So I just came from the upper meadow back there, and now I'm in the lower meadow. You've all heard the term heat rises, and so that the cold air sinks. When I walked from the upper meadow to the lower meadow down here, I could feel the change in temperature. It's actually chillier down here than it was when I was looking at the cows in the upper meadow a little while ago. And, I only went 1/10 of a mile from the upper section to the lower section, and I could feel the temperature difference. Cold air sinks down, warm air rises up. Topography is the study of the land. Where are the mountains and the valleys and the plains and the rivers and things like that. So I want to talk about a continental divide. A continental divide is basically like a ridgeline or a mountain where all of the rain that falls on this side flows down that way, and all of the rain that falls on this side is going to flow down this way. We right now are at the eastern continental divide. So any rain that falls on this side of the mountain is going to flow down toward the Atlantic and eventually run into the Atlantic. But any rain that falls on this side of the mountain goes down the other direction and eventually works its way into the Mississippi River and down into the Gulf of Mexico. So that's what a continental divide is. All right, a little more topography. So we all know that water runs downhill in a landscape. And when it gets to wherever the bottom is, it collects and starts to form a stream. So if you look at the trail behind me, you can kind of see that it's been coming downhill a little bit to where I am now. And as I walk right over to here, at the bottom of the hill here, we have a little stream. There's not much in it right now because it's been kind of dry, but there's the stream. Okay. And once I cross the stream, since water's been coming downhill from both sides, once I cross the stream, I have to start going up on the other side. The stream itself is kind of at the bottom of the V, and the water runs down both sides and collects here in the center. So generally speaking, when you are hiking and you cross a stream, you go down to it and then hike up from the other side of it. This is the sunset from my tent one evening. But the next morning, the sun wasn't rising there because it was coming up in the opposite direction on the other side of the mountain. We talk about the sun moving across the sky from east to west, but it's actually the Earth turning that makes it seem that way. From this rock outcropping, I was looking east in order to see the sunrise, and I was looking west when I watched the sun set. I can use the sun for navigation. I know that this direction is east because the sun is rising this way. It rises in the east and sets in the west. The spinning of the Earth also makes the moon appear to rise, move across the sky, and set. Here's where the moon was earlier in the evening, but a couple of hours later, it had moved over to there. So your nervous system includes your brain, your nerves, and all of your five senses, so that your brain knows what you are seeing, hearing, smelling, feeling, tasting, and all that information gets sent to the brain using nerves. So this morning, by the time I left camp, it had warmed up to 34 degrees, just above freezing. So it was really cold. And it was so cold that my fingers had gone numb. I couldn't feel my trekking poles. I was sort of gripping from muscle memory. And I had 2 pairs of gloves on. I had my gloves and my over mittens. And eventually they did warm up as I started moving, but they were so cold that not only couldn't I feel anything, like I couldn't feel my other fingers if I did this, but they were also painful. There was like a throbbing pain to them, which got me thinking about how I could not feel anything but yet still feel the pain. And that's because in your skin, we have different types of receptors, and they're each responsible for feeling or sensing different kinds of things and telling the brain. So you have receptors for cold. So if I pick up a snowball with my bare hands, the cold receptors will be triggered and it'll tell my brain the snowball is cold. You have receptors for warmth. So when I heat up my water and cook my dinner at camp and I hold that nice warm bowl in my hands, the heat receptors are triggered and tells my brain that this is nice and warm. We also have touch receptors, and that's responsible for feeling things. You know, if I run my hand over something and it feels rough, that's going to be a touch sensation. We have pressure sensors in our skin, and they feel when something is pressing. So, for example, if you go to the doctor and the dentist and he gives you like Novocaine for something, that'll deaden the pain. You won't feel any pain, but you might still feel the pressure of him working in your mouth because they're two different types of receptors. And finally, there's pain receptors, which are actually very important because when you feel pain, it's a warning that something is wrong and you should stop doing that. So apparently my touch receptors were, frozen to the point of not working, but my pain receptors were still functioning this morning. So that's why I couldn't feel anything, but it was painful. I could feel throbbing in pain. I don't know if you could tell, but it is hot and I am sweating. Everybody knows that we sweat when we're hot. It's actually a mechanism for cooling us down. Sweat is primarily water that we're releasing through the pores in our skin. And we all know that if you heat water, it will evaporate. The more you heat it, the faster it'll turn into vapor. And this is true of the sweat that's popping out on our skin also. It's using heat in order to evaporate. Now, the source of the heat is actually your body. And this is how it cools you down. It steals some of your body heat to use to evaporate the water, leaving you with a little less body heat and therefore cooler. Right now, it's kind of humid out, and so my sweat is not evaporating as fast as it normally would because humidity means the air is already full of moisture, and so the air is basically looking at my sweat and going, no, we've already got enough, you keep it. So it doesn't want to evaporate as easily when it's humid. There's just no room left in the air for it to evaporate into. The other thing that will help water to evaporate a little bit is wind, which is why when the wind blows, you feel so much cooler. It's actually evaporating your sweat just a little faster and allowing you to cool off just a little more quickly. That's true for the moisture on your skin in the form of sweat, and it's also true for moisture in the environment after it rains. When it's sunny, that adds heat and helps the water to evaporate more quickly. And when it's windy, that also helps the water to evaporate off the land more quickly. So the trail is definitely starting to dry out. Places that are in the sun are doing pretty well. Places that are still in the shade and don't have any wind hitting them are still damp, but improving. Since a lot of animals eat plants, many plants have developed mechanisms for protecting themselves. Some, like sticker bushes, grow thorns. Others, like poison ivy, have an oil that irritates the skin and causes a rash. And some plants, like stinging nettles, have tiny little hairs under their leaves that create a burning sensation when touched. When hiking, it's best to recognize these plants and avoid touching them in the first place. So if you take a look at this rock, In the sunshine, you could see it's got all these little sparkly bits in it. Those sparkly bits are a mineral called mica. And over time, as this rock wears away and crumbles into the soil, those little shiny, sparkly bits end up in the soil too. So in places, as I'm walking along and looking at the soil when the sunlight hits it, it almost looks like the soil is made up of tiny little crushed diamonds. Hope you enjoyed the science. See you back on the trail.